OK, before we leave layer 4 altogether, let's quickly talk about an alternate protocol you could use at layer 4 called UDP. So here you have a choice. As the programmer, you can either choose to use TCP or UDP at layer 4. You can't choose both. You can't choose neither. You have to choose one. And which one you choose depends on what properties you want in your network connection. So if you choose TCP, you're saying that you want reliability. You want packets to arrive in order. You want TCP to handle resending packets for you and reordering packets for you. And you want that byte stream abstraction. That's what you get if you choose TCP. But not everyone wants that. There's actually some cases where you don't need reliability. And if it's the case that you don't need reliability, maybe your choice of layer 4 protocol is UDP instead. UDP is kind of like TCP, except we don't have any of the features that we talked about. So it's like UDP is a very plain version of TCP. It still has ports, so we keep those in order to figure out which application on the computer we're sending to. But it provides best effort delivery, which means it doesn't resend lost packets. It doesn't reorder packets. It doesn't let you send long data and split the data up into packets for you. So it gives you ports and really nothing much else. If you use UDP, you are still thinking in terms of datagrams or packets. And it's your job as the programmer to split data up into packets and reassemble them if needed. And that's what UDP looks like. So it's like TCP minus everything except ports. So at first glance, you might ask why anyone might use this. It seems like this is strictly worse than TCP. But there are actually some points where UDP is better. So one thing that's nice about UDP is that it might be faster. In TCP, remember that there's a 3-way handshake before you can start sending data. So even if the data you want to send is a tiny little message like hello, if you're using TCP, you have to send SYN, ACK, SYN-ACK. I think I got those backwards. You have to send SYN, SYN-ACK, and then ACK. And only after those 3 handshake messages can you send your little piece of data. So even sending 1 byte in TCP requires waiting for 4 packets to be sent. By contrast, in UDP, there is no handshake. So if you have a piece of data you need to send, you can just fire it right away, and it gets there on the very first try without any sort of handshake. Now, you might have to resend it if it's dropped, but in some cases, this can be faster than TCP. So if you care about speed, or if you're just trying to send a very little piece of data, maybe UDP is what you're trying to do. So maybe this is a better fit for you. Also, there are some cases where you really care about speed, but you don't necessarily care about reliability. That could also be a case where UDP wins. So the most common example I can think of are live streaming applications where you're streaming a video that's live, or you're streaming a game that's live. Well, in those cases, we don't really care about every single byte arriving. It's not that I care about every single frame of the live stream arriving at my computer. I just want to watch the thing live. So even if a couple frames get skipped, I don't want to sit there waiting for the missing frame to get sent and resent and resent and resent if it gets dropped. I want to just skip that frame and go to the next one and continue watching my live video. So maybe in a case where I care more about staying up to date with the live feed, and I don't care about resending lost packets from 10 seconds ago, maybe UDP is your choice. But remember, you do have to choose one of the two. For example, because both of them give you ports, and that's something you need if you're writing an application. So you can't choose neither, but which one you choose depends on your choice of application. So for UDP attacks, it's literally 1 bullet point. There's no sequence numbers. There's no cryptography. So if anyone wants to inject data, they can just send a spoofed packet, and the data gets injected. And if you don't like that, you'll have to define higher layer protocols to defend against those attacks. So UDP by itself, just like its cousin TCP, has no built-in security. So here's the UDP packet structure. It's the smallest one I think we've ever shown. It just has the ports that we talked about, the length of the packet, and a checksum to avoid accidental corruption. But this is not cryptographic, so an attacker could change the data and then change the checksum.